day to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on complex analysis, power series lecture 8 part 2, in which I will prove the remaining part of Laurent's theorem. Now we will calculate the value of I2. For this, we find the integration along the circumference of the circle C2. Let xi be an arbitrary point on the circumference of the circle C2. Therefore, equation of circle C2 will be modulus of xi minus z naught. Z naught be the center, and this equal to rho 2. Let this is number 15. Since Z be a point in D, therefore minus 1 by xi minus z equal to 1 by z minus xi. This equal to 1 by z minus z naught plus z naught minus xi. This equal to 1 by z minus z naught minus xi minus z naught. This equal to 1 by, we take common, z minus z naught, remains 1 minus xi minus z naught by z minus z naught. Let this is number 16. Now modulus of xi minus z naught by z minus z naught equal to modulus of xi minus z naught by modulus of z minus z naught. Here xi is on the circle C2 and z naught be the center. So modulus of xi minus z naught equal to rho 2 and z minus z naught modulus is r. This is less than 1 because distance between z minus z naught, z is outside this circle C2. So this distance will be larger than the radius of the circle C2, which is r. Let this is number 17. Using 17 in 16, we get minus 1 by xi minus z equal to 1 by z minus z naught multiply 1 minus xi minus z naught by z minus z naught whole to the power minus 1. This equal to 1 by z minus z naught using binomial theorem, since modulus of this is less than 1. So 1 plus xi minus z naught by z minus z naught plus xi minus z naught by z minus z naught whole square plus dot 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 plus xi minus z naught whole to the power n minus 1 by z minus z naught whole to the power n minus 1 plus xi minus z naught whole to the power n by z minus z naught whole to the power n plus xi minus z naught whole to the power n plus 1 by z minus z naught whole to the power n plus 1 plus xi minus z naught whole to the power n plus 2 by z minus z naught whole to the power n plus 2 plus dot 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 dot. This equal to 1 by z minus z naught outside 1 plus xi minus z naught by z minus z naught plus xi minus z naught whole square by z minus z naught whole square plus dot 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 plus xi minus z naught whole to the power n minus 1 by z minus z naught whole to the power n minus 1 plus we take common here xi minus z naught whole to the power n by z minus z naught whole to the power n. We take common 1 plus xi minus z naught by z minus z naught plus xi minus z naught whole square by z minus z naught whole square plus dot 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 and bracket closed, implies that 1 by this is z minus xi, z minus xi equal to 1 by z minus z naught plus xi minus z naught by z minus z naught whole square plus xi minus z naught whole square by z minus z naught whole to the power q plus dot 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 plus xi minus z naught whole to the power n minus 1 by z minus z naught whole to the power n plus this is xi minus z naught whole to the power n z minus z naught whole to the power n and 1 by z minus z naught multiply the terms under bracket be 1 by z minus xi. This is similar to finding I1. This is number 18. Now from 3. I2 equal to minus 1 by 2 pi I integration along the circle C2 function of xi by xi minus z d xi. This is equal to 1 by 2 pi I integration along the circle C2 function of xi by z minus xi d xi. Let this is number 19. Using 18 we get I2 equal to 1 by 2 pi I integration along C2 function of xi. Value of this is 1 by z minus z naught plus xi minus z naught by z minus z naught whole square plus xi minus z naught whole square by z minus z naught whole cube plus plus xi minus z naught whole to the power n minus 1 by z minus z naught whole to the power n plus xi minus z naught whole to the power n by z minus z naught whole to the power n 1 by z minus xi d xi. Implies that I2 equal to, here variable quantity under integration be xi and z naught are treated as constant. So we may write this as 1 by z minus z naught multiply 1 by 2 pi I integration along circle C2 function of xi d xi plus 1 by z minus z naught whole square multiply 1 by 2 pi I integration along the circle C2 xi minus z naught function of xi d xi plus plus 1 by z minus z naught whole to the power n multiply 1 by 2 pi I integration along the circle C2 xi minus z naught whole to the power n minus 1 function of xi d xi plus 1 by z minus z naught whole to the power n multiply 1 by 2 pi I integration along the circle C2 xi minus z naught whole to the power n multiply 1 by z minus xi multiply f xi d xi. Implies that I2 equal to, let this quantity is B1 z minus z naught whole to the power minus 1 plus this quantity is b2. b2, this is z minus z naught whole to the power minus 2 plus dot 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 dot. This part is bn. bn z minus z naught whole to the power n minus n plus, let this quantity is Sn. Let this is number 20, where Bn equal to 1 by 2 pi I integration along the circle C2 xi minus z naught whole to the power n minus 1 f xi d xi and Sn equal to 1 by z minus z naught whole to the power n multiply 1 by 2 pi I integration along the circle C2 xi minus z naught whole to the power n multiply 1 by z minus xi f xi d xi. Let this is number 21. Implies that modulus of Sn less than equal to 1 by z minus z naught whole to the power n modulus of 2 pi I is 2 pi modulus of I equal to 1, and here modulus of xi minus z naught whole to the power n modulus of z minus xi modulus of f xi modulus of d xi. Let this is number 22. Since function of xi is analytic on the circumference of the circle C2, therefore it is bounded. Implies that modulus of function of xi less than equal to m2. m2 is a positive quantity. Let this is number 23. Again, modulus of z minus xi equal to modulus of z minus z naught plus z naught minus xi. This is equal to modulus of z minus z naught minus xi minus z naught. This is greater than equal to modulus of z minus z naught minus modulus of xi minus z naught. Implies that z minus xi greater than equal to, this is r minus xi minus z naught is rho 2. Let this is 24. Therefore modulus of Sn less than equal to 1 by modulus of z minus z naught is r to the power n multiply 1 by 2 pi integration along the circle C2 xi minus z naught is rho 2 to the power n modulus of z minus xi. This is greater than this quantity. So if we write here lesser quantity r minus rho 2, right side will be greater, and function of xi is less than equal to m2 and modulus of d xi. Implies that modulus of Sn less than equal to rho 2 by r to the power n multiply 1 by 2 pi multiply r minus rho 2 multiply m2 multiply integration along the circle C2 modulus of d xi. Implies that modulus of Sn less than equal to rho 2 by r to the power n multiply 1 by 2 pi r minus rho 2 multiply m2 and integration of modulus of d xi is the circumference of the circle C2. This is 2 pi rho 2 and this is tends to 0 as n tends to infinity. Since rho 2 is less than r implies that rho 2 by r less than 1 and this is less than 1, then the power infinitive will be tends to 0, implies that Sn equal to 0. This is number 25. Using 25 in 20 we get I2 equal to sigma n equal to 1 to infinity bn z minus z naught to the power minus n. Let this is number 26. Using 13a and 26 in 3 we get function of z equal to sigma n equal to 0 to infinity an z minus z naught whole to the power n plus sigma n equal to 1 to infinity bn z minus z naught whole to the power minus n, where an equal to 1 by 2 pi I integration along the circle C1 function of xi by xi minus z naught whole to the power n plus 1 d xi and bn equal to 1 by 2 pi I integration along the circle C2 xi minus z naught whole to the power n minus 1 function of xi d xi. This is number 27. Therefore theorem is proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.